Hey guys, welcome to today's video. In today's video, we're going to look at a Leetcode problem, and the problem's name is Buy Two Chocolates. So in this question, we're given an integer array called prices, which consists of various chocolates. And you're also given an integer variable called money, which represents your initial amount of money. And we have to buy exactly two chocolates in such a way that you still have some non-negative leftover money. So non-negative is the sense money should be greater than or equal to 0. So you would like to minimize the sum of the prices of the two chocolates you want to buy. So you have to pick the two most cheapest chocolates from the array. So in the end you are left with some non-negative money. So our task is to return the amount of money you will be left over after exactly buying two chocolates. If there is no way that you will end up with a positive or zero money left over, you will return the initial amount of money as the output. So let's take the first example given to us. This is the array. The array is 1, 2, 2. So the two most cheapest chocolates are 1 and 2. So if you add the sum, 1 plus 2 is equal to 3. So you need $3 to buy the chocolates and you're having the initial amount of 3. So cost price minus your amount available is 3. You are left over with a non-negative money. So you return that. If you were left over with a negative money, you would return the initial money as the output. So here our task is to pick the minimum sum of the prices of the two chocolates. So how do you pick the two most cheapest chocolates? Is that you can either sort the array in ascending order and pick the first two elements inside the array, and those two will be the two cheapest chocolates available, and you find the sum of those two chocolates and compare it with the initial amount. If it is greater than or equal to 0, return that, else you return the initial money. Now let's implement this in a Java program. So here, as you can see, you have to sort the initial array. This is the initial array. I've taken the same example as 1. So this contains 1, 2, 2, and this is equal to 3. After sorting also, the array remains 1, 2, 2. You find the cost of the first two elements. First two elements is 0. 0 is this and 1 is this. So 0 and 1. Add those elements. 1 plus 2 is equal to 3. If cost, which is 3, is less than or equal to money, which is also 3. If this is passing, we have to return money minus cost. Money is equal to 3 and cost is equal to 3. So you're returning 0 as the output. So 0 is the expected output. Now let's take the second example. So after sorting the array becomes 2, 3, 3. And you pick the 0th element and the first element. Those are 2 plus 3, which is equal to 5. Check if 5 is greater than or equal to money is 3. So this condition is failing. So you come out and return whatever is present inside money. Money contains 3, so you return 3 as the output, which is matching here. So the time complexity of this approach is O of n log n, because we are sorting the array in ascending order. The space complexity is actually O of 1, but quicksort uses space complexity of O of log n. So space complexity is O of log n. Now let's see how we can solve this question using time complexity of O of n in a single pass. Now let's take the input array as 3, 1, 2, 4 and the money to be equal to 5. These are the index positions. Now we declare two variables, min and second min. Min is equal to the minimum of prices of 0 and prices of 1. So minimum of 3, 1 is equal to 1. And the second minimum will be, since 1 is the minimum, obviously the 3 will be the maximum among the first two elements. So max of 3, 1. So first min is 1 and second min is 3 among the first two elements. And now we start our iteration from the next element. So you initialize these two as min and second min respectively, and now we start your iteration from index position 2, and now you check if the current element at index position 2 I is equal to 2, right? If the current element is less than min, current element is equal to 2, 2 is less than min, this condition is failing. So in the else if block we check if 2 is less than second min is equal to 3. So this condition is passing, right? 2 is less than 3. So assign second min as that current element. Second min was 3, right? So it will be updated to 2. And in the next iteration, I is equal to 3. Prices of 3, which is equal to 4. 4 is less than min, min is 1. This condition is false. Now we check 4 is less than 2. This again is false. So these are the current values. Next iteration, I is equal to 4. So we come out of the loops. And now we are having the values min and second min. And now we proceed with the previous approach itself. We find the cost of those two. Cost of minimum and second min is 1 plus 2 is equal to 3. So min cost is less than or equal to money. Money has having value 5. So 3 is less than or equal to 5. Yes, this condition is satisfying. So 5 minus 3 you return 2. So 2 will be returned as the output for this example. So the time complexity of this approach is O of n, because we are iterating through the prices array only once from starting to end. And the space complexity is constant O of 1, because we are not using an extra space to solve this question. That's it guys, thank you for watching, and I'll see you in the next video.